Welcome back. Today we will discuss the new concept that is minimum cost spanning tree. First, before going to discuss about minimum cost spanning tree, so we will discuss what is the meaning of spanning tree. So spanning tree is a form of graph, okay, but no loop. So here I am having one graph A, B, C, D. So 4 vertices are there and 4 edges are there. So this is a graph and it having a loop, and I can write this graph like this. That means A, B, C, D. So this is a subset of this graph. That means this is a spanning tree. So graph without loop, no loop here. Without loop we are calling as a spanning tree. For example, how many vertices are here? N vertices. And how many edges? 1, 2, 3, 4. And how many edges? 1, 2, 3. That means n minus 1 edges are there. So a graph with n vertices and n minus 1 edges we are calling as spanning tree. Clear? Next we will see what is a minimum cost spanning tree. What is the meaning of cost? Cost is nothing but, so while having the graph, in the graph, if edges having some weight we are calling as cost. For example, this cost is 20. Each edge having some cost. Okay, just consider to reach from A to B I will take 10 hours. To reach from A to C I will take 20 hours. To reach from C to D I will take 30 hours. From B to D I will take 40 hours. So this is what we are calling as cost. Okay. Now what is the minimum cost of spanning tree? So by using this graph I can form many subtrees, many spanning trees. Many means, so by using the formula NCR, as you people know probabilities. So NCR, that means 4C3. R is nothing but number of edges. N is nothing but number of vertices. So 4C3. So nearly NCR 4C3 means 4 spanning trees you can form. So first one is this one. Next I can form like this also. A, B, C, D. Like this also I can form one of the spanning tree. Next I can form one more spanning tree. A, C, D, B. This is also one of the spanning tree. And one more spanning tree. A, B, D and C. And keep in mind, so rule is, so spanning tree we can form by using connected graph. That means all vertices should be connected by using edges, no disconnections. And I can form spanning tree, I can form minimum cost spanning tree by using, if we are having cost for each edge. So how to form, what is the cost of this? 10, 20, 40. Next, what is the cost here? 10, 20, 30. Here 20, 30, 40. Here 10, 40, 30. So now calculate the cost. 10 plus 20, 30, 30 plus 40, 70. So this spanning tree cost is 70. Next 10, 20, 30 plus 30, 60. Next this one, so 70 plus 20, 90. And this one, 70 plus 10, 80. So in these 4 spanning trees, which is the minimum cost spanning tree? This one. So this one is the minimum cost spanning tree. And minimum cost spanning tree we can form by using 2 algorithms. First algorithm is Prim's algorithm and second algorithm is Kruskals algorithm. So let us see one by one by taking small example. Yes, as I told, minimum cost spanning tree we can form by using 2 algorithms, that is Prim's algorithm and Kruskals algorithm. So we will explain these two algorithms by taking small example. Here we are having a graph having 7 vertices and 1, 2, 3, 4, 5, 6, 7, 8, 9 edges. So this graph. So what we have to do, we have to find a minimum cost spanning tree by using Prim's algorithm first. So first we will discuss how to construct minimum spanning tree by using Prim's algorithm. Okay, here just we are having only two rules. First, we have to select the minimum edge in the graph. So minimum edge is 10 here. 10 is there. So I will consider this one first. So how to do that? So what are the connected vertices here? 1 and 6. So what is the cost of this edge? 10. So I considered. So next step, in the next step, so just to these vertices, just outgoing edges, just see the outgoing edges, which one is the least, so you have to consider. So 1 and 6, 1 and 6, so what are the outgoing edge? 28 is there, 25 is there, so which one is the least edge? 25. So I will consider 25 now. So from 6 to 5, that is 25. That is the cost of that edge. Next, you have to see now 1, 6, 5, all vertices outgoing edges. So 6 outgoing edge is already completed. Now see outgoing edges of 1, 5. So 1 outgoing edge is 28. Next 5 outgoing edges 24 and 22. So 22, 24, 28. Which one is the least? 22. So now I will consider this edge. Okay. So from 5 to 4 I will consider. What is the cost of that edge? 22. Next, I have to see the outgoing edges of 1, 5, 4. So 1, 28, remaining 24, 18, 12. So which one is the least edge? 12. So I will consider this edge now. So from 4 to 3. What is the edge cost? 12. So next I have to see now 1, 5, 4, 3 outgoing edges. So one outgoing edge is 28, 24, 18. So this one is already over, right? So next 16. So out of these 28, 24, 18, 16, which one is the least? 16. So now I will consider 16th. I mean edge with the cost 16. That is from 3 to 2, 16. So now again next step, I mean repeating the second step until we get minimum cost spanning tree. That's it. This is the Prim's algorithm. Now I want to see the outgoing edges of 1, 5, 4, 3, 2. So outgoing edge of 1 is 28, 24, 18. Yeah, that's it. 28, 24, 18. So what is the least? No, one more is there. From 2 to 7, 14. 28, 24, 18, 14. Which one is the least? 14. So now I will consider this edge. So from 2 to 7. What is the cost of this? 14. That's it. That's over. All vertices came and minimum cost edges came. 1, 2, 3, 4, 5, 6, 7 vertices. 1, 2, 3, 4, 5, 6. 6 edges. N vertices, n minus 1 edges we are calling as spanning tree, and with the least cost. This is the minimum cost spanning tree by using Prim's algorithm. And what is the total cost of this tree? I mean with this spanning tree now. So total cost 10. Here 10 plus 25 plus 22 plus 12 plus 16 plus 14. How much you will get finally? Total cost you will get 99. So now we will see for the same graph how to perform by using Kruskals algorithm. Okay, now here I will show you how to find minimum cost spanning tree by using Kruskals algorithm. Here we discussed Prim's algorithm. Now we will see Kruskals. So okay, this side we will see Kruskals algorithm. So to find minimum cost spanning tree for the given graph. So how to find? So as in case of Prims, what we did, first we selected minimum edge and we selected connected vertices minimum edge. So two steps. Here we are having only one step, that is always consider minimum edge. Okay, so what is the first minimum edge? Here 10, that is from vertex 1 to 6. So just write that from 1 to 6 edge is 10. What is the next minimum edge? 10 after 10, 12. So what are the vertices, connected vertices? 3 and 4. 3, is it visible? Yes. So from 3 and 4, what is the weight? 12. Next minimum weight here 10 after 12 after 14. So I will consider the weight 14 from 2 to 7. 2 to 7, weight is 14. Next minimum weight is 16. So I will consider this. Next minimum weight is after 16, 18. But you have to keep in mind, spanning tree should not contain any loop. If you if you consider that weight, so this will make as a loop. So don't consider 18. Don't consider that. So next minimum weight after 18, 22. So I will consider that weight from 4 to 5 or 5 to 4. That is weight is, because this is undirected graph. So you are finding spanning tree for undirected weighted graph. Undirected means edges no direction. Weighted means edges having some cost. So after 22, what is the next minimum weight? After 22, 24. But if you write this, again you are going to make a loop. So don't consider 24. Again after 24, what is the minimum cost? 25. So I will consider that. Next after 25, next minimum weight is 28. So if you consider 28, it will going to form a loop. So don't consider 28. So next, nothing is there. So stop the process and calculate the cost. So this is the minimum spanning tree for the given graph by using Kruskals algorithm. So we are always considering minimum cost. Here we are always considering minimum cost of the connected vertices. That's it. That is the difference between Prims and Kruskals. So what is the cost? 10 plus 25 plus 22 plus 12 plus 16 plus 14. So minimum cost is 99. Same thing. So for this graph, minimum cost always you will get 99, whether it may be Prim's algorithm or it may be Kruskals algorithm. That's it. And that completes your minimum cost spanning tree. And we are finding that minimum cost spanning tree, we can also call it as MST, by using Prim's algorithm and by using Kruskals algorithm. Thank you so much.